Hi, welcome back to physics. Today I'm talking about heat and temperature and how they're different. So heat is a form of energy. You can sense it in your skin through receptors. Heat is the process of thermal energy being transferred due to a change in temperature. So you can have in your hand a certain amount of heat energy, thermal energy, and it's a certain temperature as well. They're different. So just think of heat as energy and temperature as something you measure. Heat can be lost from your skin. So if you're in a cold, air-conditioned room, you can lose your heat energy. If you stand in front of a fan, you can lose heat energy. You can gain it as well. So you could gain it from sunshine rays, radiant heat from a fire. So I want you to pause the video and think. If you are sitting next to a fan, how does that fan, simply by moving, cool you down? After all, a fan is possibly even producing heat. If you touch the fan after you turn it off, it might actually feel warm. So how does it cool us down? Try watching the video to find out more. I'm going to talk about ways that heat transfers. The first way I'm going to talk about is conduction. So heat from your hand will go into an icy cold drink. It will heat up the ice and the water. So conduction is about the movement of particles passing on the energy from one particle to another. The particles themselves don't move along the metal rod, but the heat energy moves along the rod so that particles are bumping into each other. They're heating up because of the candle flame, getting more kinetic energy, bumping, and the heat will slowly transfer along the metal rod through conduction. So heat flows from hot to cold. That's the way heat flows. Hotter substances have faster moving particles than cooler substances. You can think about this when you think about a thermometer. The particles are getting faster and faster as the thermometer heats up, so they're spreading out. Heat transfers through particle vibration, and something to really think about, gases are actually bad conductors, so air. So how would a jumper help you keep warm in a cold climate? If you want the answer to that one, think about between your skin and the jumper, there's not a large amount of gas anymore. So the heat is vibrating and rebounding off the jumper, warming yourself up, keeping that hot air or that heat energy inside you. The next way to think about heat transferring is convection. As the air or the liquid heats up, it rises. So this is about the particles moving with the energy. So the particles, they might be the ocean, water, start to vibrate faster and faster, and they turn into a gas. So the particles themselves are rising with the energy, and they're moving further apart. The hot air or the hot water or the liquid is less dense than the cool air, so it rises, and then when it cools down, it goes back down again. So this happens every day outside. During the day, warm air on top of the land rises, and the cool air above the ocean drops. How does heat energy transfer through space from the sun to Earth? Why is it cooler in the shade outside? This is all to do with our third way of heat energy transferring, radiation. It transmits heat as invisible waves. So the particles aren't bumping into each other, the particles aren't moving in a circle. It's invisible waves that travel at the speed of light. Infrared radiation is heat energy that is transferred in this way, and all objects release this, whether it's a lot or small amounts. Again, let's pause and wonder, can humans feel temperature? If you had a piece of metal and you had a book, and you put them both in the fridge. So they're sitting in the fridge, they get to the fridge's internal temperature, you take them out, and what happens? The metal feels colder than the book, even though they're the same temperature. This is really the difference between temperature and heat. Watch that video to find out more. Minute Physics, a great channel to check out. Temperature is measurable using thermometers. So in our example, even though they were the same temperature, my hand was losing its heat energy faster to the piece of metal than the book. So temperature, it's a measurable quantity. Heat is the energy of the particles within an object. So you can have the same temperature, book, metal pen, but they'll have different heat energy because it's the way the energy is being transferred. A great example of this, if you cook on a stove, one pot that has heaps of water in it and one pot with not much water, you put a thermometer in, they have the same temperature, 100 degrees Celsius. Which one has more energy? It's the one with more. What do you think? More particles. In the bigger pot, there's more particles, so overall, in that pot, there's more heat energy. So, really, I hope you understand the difference between heat and temperature now. All right, so you're probably used to a certain measurement, i.e. certain units for temperature. In case you didn't know, there are multiple different units for temperature. And these are based on historical discoveries about different quantities. So you can see from the middle one, in Australia we use Celsius, and you can see what Celsius is based upon. So it's based on the freezing point of water. Fahrenheit, not so obvious. So a scientist had ice and salt mixed together, and those freezed at 0 degrees Fahrenheit, and his body temperature was 100 degrees Fahrenheit. So he had a thermometer and based the scale using those two amounts, creates the Fahrenheit scale. We then have the Kelvin scale. The Kelvin scale is based off the vibration of the particles. So again, heat is microscopic kinetic energy. So small particles vibrating. At what point do these particles stop vibrating? This is called absolute zero. And this is what this Kelvin scale is based upon. When you get to 0 Kelvin, that's when the particles stop moving. Thinking about these things, this is where we get our conversion equations from. The main equation I want you to know is how to convert from Celsius to Kelvin, because you may need to consider something in Kelvin degrees. So if you have, say, 20 degrees Celsius, you simply add 273 to that number and you have the equivalent temperature in Kelvin. I hope you've learned something about heat and temperature that you can use. Thanks for watching.